Okay, so question number 6. Ethanol is the active ingredient of alcoholic beverages. It is also a possible replacement for gasoline. The complete combustion of ethanol forms carbon dioxide and water. Balance the equation, and what mass of carbon dioxide is formed by the complete combustion of 775 grams of ethanol? Okay, so let's write out ethanol. Reacts with oxygen to form carbon dioxide plus water. Okay, so now we need to balance this combustion reaction. And it's easy when you balance out your carbons first. So step 1 is to balance your carbon. So if we look at our reaction, you'll see that there are 2 carbons on our reactant side and only 1 on our product side. So we just need to put a coefficient of 2 in front of CO2. So now I like to balance my hydrogens next, because if I balanced my oxygens first, then you'll see that oxygen is both in CO2 and in water. So we only want to do it like once instead of having to redo all our coefficients. So that's why I balance hydrogens next. So we have 3, 4, 5, 6 hydrogens on our reactant side and only 2 on our product side. So we just need to put a coefficient of 3 in front of H2O. So now that both of my carbons and hydrogens are balanced, we can finally balance oxygen. So on our product side, we have a total of 7 oxygens. And on our reactant side, we only have 3. So the easiest way to have 7 oxygens here is to just add a 3 in front of O2. So now we have our balanced equation. So now let's try to answer the next part of the question. What mass of carbon dioxide is formed by the complete combustion of 775 grams of ethanol? So let's write down everything we know. We know the mass of ethanol is 775 grams. And we also need to calculate the molar mass of ethanol as well. So I'm going to denote ethanol as ETOH. And its molar mass is equal to 2 times the molar mass of carbon plus 6 times the molar mass of hydrogen plus the molar mass of oxygen. So if we look at our periodic table, we'll see the molar mass of carbon is 12.01 grams per mole. And the molar mass of hydrogen is 1.01 grams per mole. And the molar mass of oxygen is 15.99 grams per mole. So now, if we add all of these values up, we get a total molar mass of ethanol equal to 46.07 grams per mole. Okay, so we are looking for the mass of carbon dioxide. So let me do this in a different color. Mass of CO2 is equal to grams. And we can also find the molar mass of CO2 just by using the same method we did earlier. So 12.01 plus 2 times 15.99 gives us a molar mass of 44.01 grams per mole. Okay, so this is everything that we are given in the question. And now step 1 is to find the number of moles of ethanol. So we do that by using the equation number of moles is equal to mass over molar mass. So the mass of ethanol was 775 grams, and the molar mass we calculated to be 46.07 grams per mole. So now if we just divide the two, we end up with 16.82 moles of ethanol. Okay, so step 2 is to use the mole ratio to find the number of moles of carbon dioxide. So we know that we have 16.82 moles of ethanol. And then by looking at our balanced equation, we can find out the mole ratio we need to find the number of moles of CO2. So we know that 2 moles of CO2 is formed for every 1 mole of ethanol. And we can double check that we did the molar ratio correctly if you see that the moles of ETOH cancel out, and we're left with the number of moles of CO2. And when you multiply 16.82 by 2, you get 33.64 moles. And this is of CO2. So finally, we can now do step 3, which is to find the mass of CO2. So we know that the mass can be found by multiplying the number of moles times the molar mass. So we found the number of moles in the previous step, which was 33.64 moles of CO2. And we also know the molar mass of CO2, which is 44.01 grams per mole. So now if we multiply these values, we end up with 1,479.82 grams. Or we can write this in kilograms. So just by dividing by 1,000, you get 1.48 kilograms. Okay, so now let's see what the junior tutor said. A balanced reaction refers to a chemical reaction wherein the number of atoms both present in the reactants and products are equal. So they summed up how many of each atom were on both the reactants and the product side, and they showed it step by step and found the balanced chemical equation to be the following, which is what I have as well. So they balanced it correctly. And now they want to convert the mass of ethanol to the mass of carbon dioxide using the stoichiometric ratios given in the balanced equation. So they have the molar masses for both. And they did it in one step. So first you find the mass of CO2 is equal to the moles. Yep, so then they showed how you would calculate number of moles, mass over molar mass. And they got 16.82 moles of ethanol. And then they used the mole ratio and then multiplied by molar mass to get a final mass of 1,481 grams, or 1.481 kilograms. Okay, so this solution is correct.